Kuzu Zangpo and welcome to my tutorial video on the topic learning Liscat software with Tenzin Doji. And I would like to take this moment to thank Sanimish for his wonderful opportunity and never-ending inspiration, and without whom this would only have remained as a dream. And once more, I'd like to thank him for making my dream come true. Now the must know informations, the informations you should know before you jump on to this tutorial video are the excavated ground level and the natural surface level. The excavated ground level, which is abbreviated as EGL, it means the level of the ground after the excavation is done. So the points that is collected, the survey points that are collected after the level of the ground that is excavated is known as the EGL point, and the points that are collected when the ground is undisturbed is known as the NSL point. So you should keep these two points in your minds before you hop on with the tutorial. Now you must be wondering, what worth it would be, spending your time on watching this tutorial. So what will you learn from this tutorial? So what one will learn from this tutorial is, after taking out the cross sections of the EGL data point and the NSL data points, we merge it. So in merging these two data, we would get the area of the excavated level. So when we multiply the area that we got with the distance interval that we set, it gives us the excavated volume that is needed by the contractor to pay for the amount of work that they have done. So it comes very handy, or this skill is very much needed as an engineer. And also you'll be able to learn how to create a counter topo in Liscat and take it into AutoCAD for your design works. With this, let's get started with the tutorial video. Welcome to the tutorial of Liscat software, and the version that I am using is 12.0, and as described in the beginning of this video, you would probably get two sets of data, that is EGL and NSL. EGL stands for excavated ground level data points that are collected by the surveyors with the help of instruments like total station after the excavation has been done on that particular site, and you would get another data, that is NSL, natural surface level data points that are collected prior to excavations being done. So we would take out the cross sections of both the data, but the first data that we want to do would be so we want to do on the natural surface level data point. So we would take out the cross section of the NSL data point first. In order to do this, you need to create a project. So to create a project, you click on a file on the left top corner of the screen. We click on file, click on new, and it will be probably better for you to, if you can create a folder, a separate folder to store the project. So you look to on this get tutorial video 2. So you click on file, click on new, and have a folder on desktop. This get tutorial video 2, and the first C section that we want to take out is on the natural surface level data point. So I'm going to keep my file name as NSL and click OK. So this is your project screen, your interface, and it's titled NSL. So click on talks, and all these options or talks is itself an entire entity of itself. Meaning, if we right now we have under utilities we have file, edit, maintenance, but if you click on data conversion, then it will be edit, import, export. So which means that it itself is an entire function of itself. The first thing that we do is we export, or we import the data. So in order to do this, we click on import, and we click on user definable, and we select the file that is the NSL collected by the surveyor, and click on OK. This is the user definable import. You can twin this point ID is not elevation code and descriptions as per your need, but I'm keeping it in a serial wise. So click on OK and click on cancel. So this is the point of the natural surface level data points collected. And this point is collected during my time at Yungichu Hydropower Project, which is located at Lindsay during OGT time. So in order to delete these lines, you click on this delete line, and then you click on the lines, so it will be deleted. Then you close it, then you scroll a little bit, and you'll see your points there. And right click on the screen and click on display features, and you click on the points, and you want to customize how you want to make your data appear. So I want to make it appear with the process. So click on process. If you need identifiers, you can do it, but at the moment I don't want it, so process will be okay. Click on OK. So this is the data, and on the left vertical toolbar you would see a cross sign with a background purple one. So if you click on it, then it would make your data appear in a fixation. So now you click on tasks, you click on terrain modeling. So what we're going to do is we're going to validate whether the points we have collected are valid or not. So under modeling, we click on validation, and you can set the region size as per your need, but a region size of 500 takes care all my data points here, so I'm keeping it 500. Click on OK, click on OK, and validation has been done. Again, you click on modeling, you click on form model. Now you're modeling your data. So set a name for your model. We like to keep it same modeling of NSL. So I've kept the region 500. Okay, so we have seen a blink of model formation being done. So okay, and now right click on the screen, you have display features. On display features, you click on model. On the model, you click on contours. So you want to join all those lines with the contour lines, and you select values here and click on OK. So this is the topography of the Yungichu hydropower project. And if I describe a little bit, this area is where the powerhouse at Yungichu hydropower project will be soon coming up. So you want to take out the cross sections of this powerhouse region. So now you click on tasks, you click on computations, and you select the method as freehand, and then you want to mark the sections where you want to take out the cross section. So you do it by freehand, click on it and take out the sections as per your need. Click on and once you are done with the marking, and then you close it, and then again under tasks you click on profiles and design. So under profile and design, you click on create, and you want to define your corridor of interest, your region of interest, the study area. So click on corridor of interest and click on, right now the corridor of interest, it's based on table formation. So you click on change, and you want to pick up the beginning of the point. So you click on change and you click on the beginning of the point. So it's 0. And here the offset means you want to take out this much distance right to the section and left to the section, so you're creating a region of your interest. So I'm going to take minus 10 left 10 meters to the section, and positive 10 meters to the sections, and you're defining a region. You add it, and then again you click on the end of the sections where you have marked. So this one 72.188, 72.188 is done, and you keep the sections offset similar. Click on add, and then you click on apply. So this is the region of your interest, so the software will take care only this much, this part of the region. And you close it, and then you under create, you click on section markers. Right now the method is by chainage. We don't want to do it by chainage. We would change the methodology to by range. So the start chainage is 0. So if it's not 0, you should probably click on to 0, but mine is already tuned, so it's 0, and the end one is 72.188. And the intervals, you can set the intervals as per your need. The smaller the interval that you keep, the accuracy will be higher, but you have to keep it 3. So interval 3, and you click on OK. So yeah, you have marked the sections. The section markers are activated. You close it, and now under profile, you click on profile. So we want to take out the cross section of that section. So cross section grade. So set a name for the cross sections and keep it C section of natural surface level. of initial service level of Powerhouse page, and you click on the parameters, and you should probably switch this to model because we're building a model. So build cross sections from not object but click on to model, and then you can also select colors of your choice. So I'm going to keep it red, and click on OK, and then you want to create the cross sections. Great. So this is the cross sections of the natural service level. So this much is done for the natural service level, and again we create another one for the EGL. So in order to do this, we close the software. Again we start to open the software again for the other data, that is EGL. So from now on it's the similar steps. It is the same step. So click on file, click on new, you create a project for your, so it's excavated ground level. So I'm going to store it on my folder. Click on OK. So you import the data. So how do you do it? So you click on data conversion, click on import, click on user definable, and this page here is my EGL point collected. So OK, and click on OK, cancel. So this is the excavated ground level data points collected. So in order to delete this line, we click on delete line. You click on the line, so it's deleted. So close it and explode your mouse a little bit. So there comes your points, and to make it up to your mark, so you right click on it, display features, on points, and you click on process. That's how you do it. If you need more, you can do it, identify the group or everything. So okay, and so this is the topography of the excavated ground level. And now you go to stocks, similar one, terrain modeling. Under modeling you do validations and you do okay. So now there's no error in this. Now the form model, set a name, the terrain modeling of EGL. So you click on OK, you see a flash of a rectangular blink class. Good. Okay. Now display features, and under model you click on contours, and you can either select lines or values, but I'm going to select on values, and okay. So this is the topography of the excavated ground level of the powerhouse at Yungichu hydropower project. Now you click on tasks, you want to compute the section from where you want to take out the cross sections. So under computations and under create, you click on alignment, not by range, I want to do it by freehand, and you select the sections and you click on end, close it. So you have marked your section, and then again click on tasks, and then you do it on profile and design. Now you're going to design it. So click on create, you want to define the corridor of interest, and it's similar to the earlier one that we have done. Click on change it. So you set your offset distance, then it's just for 10 meters. Add it 7, add it, and then apply. So you have defined your region of interest. Close, you want to mark it. So create section markers, you want to do it by the methodology under by range. So keep the intervals at 3. Okay, so here the section has been marked. Close, and again under profile, under cross section, click on create, and now we have the C section of the EGL of powerhouse. And click on parameters, you click on model because you're modeling, and you can choose the color of your choice. So I'm going to keep blue, okay, and then create. So this is the cross sections of the excavated ground level point. Now you can close the smaller close button, not the bigger one. So you can close the smaller window here, close it, and then now you want to merge the two data, that is the EGL and the NSL data. So in order to do this, you click on profile, cross section, create. Now what we are trying to do here is we're trying to bring out the earlier cross sections that we have created, that is the NSL. So we set the name as the merged section, and under parameters you bring out, you can browse it, and then you can bring out the earlier data point. So the other cross sections that we have done is the NSL. So click on NSL and then open it and tell modern NSL. Okay, and create it. So this is the cross sections of NSL, and then to bring out the cross sections of the EGL, you click on the cross sections on the left top toolbar. So cross sections, you click on open those, and then you click on the C section of the EGL-PH. So we are merging the two data. So you click on open. So here you see that we have merged the two cross-section profiling, and the area between the merged two area is the excavated one. So this is the merged section of the two data. And in the next video, we will take out this merged section into the AutoCAD, and we'll find out the area and we'll calculate the volume of the excavated level. So I hope I see you guys there.